Hello everybody. Today we're going to talk about right triangle trigonometry. Now some of you guys may have seen this before in your geometry class, so hopefully a lot of this isn't super new for you guys. So what we're going to do is we're going to talk about what trigonometry is. And trigonometry is actually the study of angles and side lengths in a triangle. In fact, the word triangle is almost in trigonometry. Okay, a trigonometric ratio is a ratio of the lengths of two sides of a right triangle. Now, it's very important that you guys know that trigonometric ratios can only be used with a right triangle. Okay, these ratios are given specific names. So, trig ratios and a way to remember the ratios is using the acronym SOHCAHTOA. And I'm sure you guys have heard this one before as well. So SOHCAHTOA is actually using sine, cosine, and tangent and their ratio of the sides. So the first thing we have is sine, spelled out fully S-I-N-E, but we abbreviate it using S-I-N, which we're going to pronounce sine. Okay, and sine of A, this angle here, is the length of the opposite side over the length of the hypotenuse, or opposite over hypotenuse, which is where you get your SO from. Now, for cosine, we have cosine, the full spelt out word is C-O-S-I-N-E, but we also abbreviate that too. You'll see these words on your calculators of C-O-S. We're going to pronounce that cosine when we're talking about them. So we have cosine of A is equal to the length of the adjacent side, which is here in comparison to A, over the length of the hypotenuse. So we have our A and our H. So we have cosine is the ratio of the adjacent side of the hypotenuse, or that's the ka part of our acronym. The last one we have for now is tangent, and tangent is spelled T-A-N-G-E-N-T. We're going to abbreviate that as T-A-N, but again, we're always going to say the full name, so tangent of something. So we have tangent of A is equal to the leg of the opposite side of A. So we have the opposite side of A over the adjacent side. So you'll notice here that tangent does not include the hypotenuse, but sine and cosine do. And if you look, we have opposite and our adjacent, and that's where we get the OA in the TOA. Okay, so we have SOHCAHTOA. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So let's do a couple problems here. We have sine of B. For first, we need to find angle B, which is right here. So sine of B is going to be your opposite side over your hypotenuse. So we know that sine of B is going to be equal to the opposite side. So the opposite side is right here at 8. And the hypotenuse is the side opposite the right angle, or the longest side, which is 16. So sine of B is equal to 8/16, which can be reduced to 1/2. So now let's do 27, which says cosine of D. So first thing we're going to do is we're going to find angle D. And remember that cosine of D, that's a B, is going to be the adjacent side over the hypotenuse. So we're looking at this angle here, and the adjacent side is right here. The adjacent side always touches the angle that we're looking at. And then we have our right angle, and the side opposite of that will be our hypotenuse, which is 8√2. So we have 8 over 8√2, which reduces down to 1 over the square root of 2. But you guys all know that we cannot have a radical in the denominator, so what we're going to do is we're going to rationalize it. So we're going to multiply the top and the bottom by the square root of 2. And when you do that, you get the square root of 2 over root 2 times root 2 is just 2. So this is our answer. So root 2 over 2. Now let's do a tangent one. So we have tangent of D. Again, we're looking at the same angle D right here. And we know that tangent of D is the opposite side over the adjacent side. So the opposite side is 8 right here. And the adjacent side is also 8. So tangent of D is going to be 8 over 8, or simplified down to just 1. Okay, so let's try some trickier ones because now we have some trickier angles. So we're looking at sine of angle DAC. Okay, so DAC, what you're going to do is you're going to start here and you're going to follow the angle. So we have D, and then we're going to go up to A and then C. So the angle that we're really looking at is right here. Okay, and we're looking for sine, so we're looking for sine of DAC is going to be the opposite side over the hypotenuse. The opposite side to A is right here, and that is 8. And then we were looking for the hypotenuse, which is right here. I'm trying to bold it. I hope you guys can see that. And that's going to be 8 root 2. The cool thing about this is we've actually already done an example like this, so we don't really have to do a whole bunch more math because if you look, we have the same thing here, and we know that's going to reduce down to root 2 over 2. Okay, so the next one we're going to do is tangent of B. So first thing we got to do is we got to find our angle. Again, our angle is over here. This one's a little bit easier than the last one. So we have tangent of B is equal to opposite over adjacent. So our opposite side to B is right here at 8. So we have 8, and our adjacent side is right here at 8 root 3. So this is very similar to 27 and 29. So we're going to reduce it. So we have the 8s will cancel out here. So now we have 1 over the square root of 3. We're going to rationalize that denominator by multiplying by root 3 over root 3. And that's going to give us the square root of 3 over 3. So tangent of B is root 3 over 3. And last but certainly not least, we have cosine of BAC. So again, we need to find where that angle is. We're going to start at B. We're going to go up to A, and then we're going to go back down to C, which means our angle that we're looking at is right here. Okay, so we're looking for cosine of BAC. So we're looking for the adjacent side over the hypotenuse. So the adjacent side to this angle is right here at 8. And our hypotenuse is this side right here, and that's 16. And 8 over 16 reduces down to 1/2. So we have just found 6 trigonometric ratios. Hopefully you guys have followed along. We're about to do some more ratios. So, we're going to use our calculators. Okay, so what we're going to do is we're going to determine the value of each ratio using your calculator. We're going to round this to the nearest hundredth. Now, before we do this, I want you guys to realize that all of these are in degrees. Okay, so that means you want to make sure that your calculator is also in degrees. Now, depending on what type of calculator you have, this process might be different for you to make sure your calculator is in degrees. If you guys have any questions on how to do this, I'm going to try to see if I can find some resources to help you with this. Or, of course, you can always email me and I can help you find that. So now that your calculator is in degrees, you're in degree mode. Gotta make sure that is going on. Okay. What you're going to do is you're just going to look at your calculator and you're going to find sine of 60. And when you put that in your calculator, I'm going to get my calculator out right now. Let's turn it on. Okay, I'm going to put in sine of 60. So when I do that, I'm in degree mode. So when I do sine of 60, I'm going to get to the nearest 100th, 0.87. There's not a lot of work to show here. This is all calculator work. The important part is that you guys are getting the same answer when you are putting in your calculator to make sure that you know how to do it and your calculator is in degree mode. If you did not get 0.87 and you put sine of 60 in your calculator, that means that your calculator is probably in radian mode. Okay, so let's make sure that we get that in the correct mode. The next thing I want to do is I want to find tangent of 45. So I'm going to put tan 45. I like to end my parentheses. Sometimes you don't have to, but if you're not getting the right answers and you're in degree mode, that could also be a reason why you're struggling. So when you put tangent of 45 in your calculator, you should be getting 1. So now we have cosine of 30. We're going to put that in our calculator. And you'll see that cosine of 30 and sine of 60 actually have the same answer. And we're going to talk more about that when we get to the unit circle in the next couple of days. So we got 0.87 for cosine of 30. Now we're going to go down to some more interesting numbers. We have tangent of 52. So you're going to put that in your calculator. and you're going to get 1.28. And last but certainly not least, we have sine of 64. So you're going to do sine of 64 in your calculator. And you're going to get, well, this one rounds, so you're going to get 0.90. Because what your calculator should show is 0.898794046 But again, we're rounding to the nearest hundredth. So we're looking at this decimal. This will round it up, so the whole thing becomes 0.90. So we have 3 more trig ratios that we need to discuss, and those are cosecant, secant, and cotangent. And what they are is they're actually reciprocals of the first 3 that we learned. So let's look at the first one. We have cosecant, abbreviated CSC, and that is the length of the hypotenuse over the length of the opposite side, which if that sounds really familiar to you, you should notice that that is actually the reciprocal of sine. So cosecant of A is actually 1 over sine of A. So cosecant is hypotenuse over opposite. We also have secant, abbreviated SEC, and secant of A is going to be the length of the hypotenuse over the length of the side leg adjacent to angle A. And that's going to be H over A. And again, if you flip these, you'll get cosine, because secant is the reciprocal of cosine. So secant of A is equal to 1 over cosine of A. And then, of course, we also have cotangent. Cotangent, abbreviated COT, is going to be the length of the adjacent side to angle A over the length of the opposite side to A, or A over O, which should look again familiar because that's the reciprocal of tangent. So cotangent is equal to 1 over tangent. And these are actually very important identities to remember, because we're actually going to, in our next unit, we're going to be talking about different ways we can prove other identities using trigonometric identities. So if you guys learn these now, it's going to help you a lot more in the future. Now, I do want to point something out. You'll notice that cosecant and secant have the same letters of sine and cosine, but if you look, cosecant matches up with sine, and secant matches up with cosine. I think the biggest mistake I see here is kids switch these. They think that cosecant is the reciprocal of cosine, and secant is the reciprocal of sine, just because of these first letters. But I'm just telling you now, and hopefully that will prevent this mistake from happening, that it's actually the opposite, okay? So think reciprocal, not exactly opposite, but you're just going to flip them. So flip the C and the S. So we're going to do some more examples, and these should look pretty familiar because we literally just used this triangle a couple minutes ago with our other 3 trigonometric identities. We have cosecant of B. So we're going to find B first. And if you guys remember, cosecant of B is the hypotenuse over opposite side. So we're looking at the hypotenuse, which is 16. And we have the opposite side, which is 8. So cosecant of B is going to reduce down to 2. Now, secant of D, so we have secant of D, is going to be the hypotenuse over the adjacent. So let's find D. It's right here. So we're looking at the hypotenuse, which is right here. It's 8 root 2. And the adjacent side is 8. So we have 8 root 2 over 8. That's going to reduce down to the square root of 2. We also have cotangent of D. Remember that cotangent is adjacent over opposite. So what we're going to do is we're going to find the adjacent side, which is 8. And then we have the opposite side, which is also 8. And that will, of course, reduce down to 1. Now we're getting back into the trickier angles again. We have cosecant of DAC. So remember, we start at D, we go up to A, down to C, which means this is our angle right here. And remember that cosecant is hypotenuse over opposite. So we're looking at the hypotenuse here, which is 8 root 2. And the opposite side is 8. So we have 8 root 2 over 8, which is going to reduce down to the square root of 2. you guys may have caught on, but all of these answers are the reciprocals, the answers that we have in our 6 previous examples. Okay, so we also have cotangent of B, which is adjacent, wrong parenthesis, which is adjacent over opposite. So we're going to look at B, which is back over here again. So we're looking at the adjacent side, which is going to be 8 root 3. And we're going to divide that by our opposite side, which is 8. So this will reduce down to the square root of 3. And last, but again, certainly not least, we're going to look at secant of BAC. We're going to start at B. We're going to go up to A, down to C, which means this is our angle right here. So remember that secant of BAC is equal to the hypotenuse over the adjacent side. So our hypotenuse is 16, and our adjacent side is 8. 16 divided by 8 is just 2. Okay, so you'll notice when you guys look at your calculator that you don't have a secant, cosecant, and cotangent on your calculator. Okay, so what you want to do is you have to use the reciprocal identities. So in order to find cosecant of 30, what you're actually going to have to do is 1 over sine of 30. So you'll have to type 1 divided by sine of 30 into your calculator. And if you do that, which I'm going to do right now, so 1 divided by sine of 30, make sure you guys are ending your parentheses here. You should be getting 2. Okay, so let's try to do these in our calculator. So we have cosecant of 60. So what I'm going to put in my calculator is 1 over sine of 60, because sine is the reciprocal of cosecant. I'm going to do 1 divided by sine of 60 in my calculator. And I should be getting 1 point, and we're rounding this to nearest hundredth, so we're going to get 1.15. For the next one, we have cotangent, which is going to be 1 over tangent of 45. Okay, so you're going to put 1 divided by tangent of 45 in your calculator, and you'll still get 1. Makes sense. The reciprocal of 1 is 1. Okay, now secant is going to be 1 over cosine of 30 degrees. So we're going to put 1 divided by cosine of 30 in our calculators. Okay, and you're going to get 1.15 again. Now, cotangent of 52, we're going to do 1 over tangent of 52, because tangent is the reciprocal of cotangent, right into your calculator. So we have 1 divided by tangent of 52, and that's going to give us 0.78. And then again, last certainly not least, we have cosecant, which is going to be 1 over sine of 64. So we're going to do 1 divided by sine of 64 right in your calculator. Again, you want to make sure that this is in degree mode. If your answers are not matching up, that's probably the problem. So you have 1.11. So now we have all of these ratios. What are we going to do with them all? Well, we can use the ratios to solve a trigonometric triangle problems. So what you're actually going to do is I would really like you to take this time to find the link in Google Classrooms and watch this little music video, because it has some great lyrics that will help you to solve triangles in the future. Now, I'm not going to play it here. I really, again, really like you to watch it on your own time. If you're in my class, I'm going to make you watch it. But if you're at home right now, I want you to watch this. The link is in Google Classroom. But let's talk about something that's in, if this will let me move on to the next slide here. Oh no. Okay, so we have some lyrics from the actual song here. So the important part of the whole thing was, if you see an x up high, so let's say that you have sine of 30 is equal to x over 8. So what are you going to do when you see the x up high? That's when you know how to multiply. So what you're actually going to do is you're going to multiply both sides by 8, or you can just multiply by the denominator here, and you can actually put this all into the calculator to solve for x. The other option is when the x is down below, and that's when you know the x and the angle will switch, you know. So the x will come over here, and the sine of 30 will go down where the x was. This is just using proportions. We could put this over 1 and then do cross multiplication to get 8 is equal to x times sine of 30, and then you would have to divide both sides by sine of 30. Now, you can do this every single time. There's nothing wrong with this. I just think that a lot of kids have used this little rhyme in the past and has saved them a lot of time and struggles. Okay, again, if you want to do proportions, 100% fine. Again, I'm just trying to give you a little tip or trick to solve these in the future. So what we're going to do now is we're actually going to put what we just learned to use. So we have 60 degrees down here, and to 60 degrees, we have the opposite side is 15, and then the adjacent side is x. So because I only have these two legs, the opposite and adjacent side, what I'm actually going to do is I'm going to use tangent, because tangent is opposite over adjacent. Okay, so what we're going to have is tangent of an angle 60 is equal to your opposite side, which is 15, over your adjacent side, which is x. Now, my x here is down below, so that means the x and the angle are gonna switch, Now, I said, no, that sounds ridiculous, but I promise this will help over the long run. So the x is gonna come over here, and then we're gonna have 15 divided by tangent of 60. And what you can do is you can just put that directly in your calculator. You're going to do 15 divided by tangent of 60. And you're going to get 8 points, and we're looking for the nearest tenth here, so it's going to be equal to 8.7. Okay, so these guys both have two variables that we're solving for. So let's start with E, just because it comes first. So E is our opposite side to our angle of 35, and F is our adjacent side. Okay, so let's start with E first. Oops, I went back. So because I have my hypotenuse and I'm looking for the opposite, I'm going to use sine, because sine is opposite over hypotenuse. So we have sine of 35 is equal to E over 12. Now, because the x is up high, and in this case the x is just the variable, we're going to multiply. So E is going to be equal to 12 times sine of 35, which you can put directly into your calculator to get 6.9. Now to look for F, it's the adjacent side, and we have the hypotenuse. Now, you guys could use other ratios here now that you also have the opposite side, but I pose a question for you. What if this was wrong? And then you use that wrong answer to find all of the other answers. Well, unfortunately, if you have a wrong answer to start with, every answer afterward is also going to be incorrect. So my suggestion is you use what's given to you in the problem, in this case, the 12. So now we have the adjacent and hypotenuse, so that means we're going to use cosine, because cosine is adjacent over hypotenuse. So cosine of 35 is going to be equal to F over 12, adjacent over hypotenuse. And because, again, the variable is up high, we're going to multiply. So we have F is equal to 12 times cosine of 35. Something I should really point out here is try to put this number first, because if you put it after the cosine of 35, unless you're using proper parentheses, things can get a little messy. So what we're going to do is we're going to put that into our calculator. So we have 12 cosine of 35, and that is going to give us 9.8. I also like to look back at the original question to make sure that my answers make sense. Now, because this angle here is 35, then this angle is going to be bigger. It's actually going to be, what, 55? And because this angle is bigger, that means this side is going to be bigger than this side. So it makes sense that 9.8 is bigger than 6.9. And it's just a really easy way to quick check your answers. You guys could do the Pythagorean theorem to check your answers. You could have found the side using the Pythagorean theorem if you wanted. This just gives us a more accurate, and I think it's actually a little bit quicker sometimes than the Pythagorean theorem. So we're going to have this last example here. We're looking at all of these sides. We have this angle of 55. So this side right here is the hypotenuse. This side right here is the opposite side. And H is going to be the adjacent side. So I'm going to solve for G first. Yeah, because it comes first. You may have just heard me doing the alphabet in my head. So what we're going to do is, because we're looking for g, which is the opposite side, and we're given 15, I'm going to use sine. So sine of 35 is equal to the opposite side g over the hypotenuse, which is 15. Now, again, the variable is up high, so we're going to multiply. So we have g is equal to 15 sine of 35. You're going to pop that right into your calculator. 15 sine of 35. Oh, 55. Oh my goodness, I've been using the wrong angle this entire time. So 15 sine of 55 is going to be 12.3. Okay. The next thing we're going to do is we're going to find this h. So this is the adjacent side. Again, I have the hypotenuse. So what I'm going to do is I'm going to use cosine of 55, because that's equal to the adjacent h over the hypotenuse 15. And again, because the x is up high, we're going to multiply. So we have h is equal to 15 cosine of 55. You're going to pop that right into your calculator, 15 cosine of 55, and that's going to give you 8.6. So this is how you find missing sides of a triangle given an angle and one other side. You can actually solve an entire triangle this way. So, interesting. I don't know why this slide is right in the middle here. Okay, so what we're going to do is we're going to now use the inverse operations, and we're going to use these to find angles given the ratio of two sides. Okay, so to find an angle measurements, we actually use the inverses of these trig functions. Now we have the inverse of sine, or sine to the -1. We can also call this arc sine, and that's actually a little bit easier to say sometimes. So you might hear me say inverse sine, you might hear me say arc sine. We also have inverse cosine or arc cosine. And we have inverse tan or arctan. And you'll actually find all of these little keys right above where your sine, cosine, and tangent buttons are on your calculator. On most calculators, you have to press the second button, which should be in the top left-hand corner of your calculator. And again, because we're looking for angle measurements right now in degrees, we need to make sure your calculator is also in degrees. So we're going to solve a couple problems here. So I want to find angle A and I want to find angle C. So I'm going to solve for angle A first, and there's really no preference here, just A comes before C in the alphabet. And now I have the opposite side and I have the adjacent side. So I know that because I have opposite and adjacent side, I have tangent of angle A is equal to my opposite side over my adjacent side. Or in this case, it's going to be 30 over 20. Now, to get A by itself, I need to take the inverse of both sides. So A is equal to arc tangent or inverse tangent of 30 over 20. Okay, so what I'm going to do is I'm going to put this in my calculator. So I'm actually going to press second tangent, and then I'm going to do 30 divided by 20. And when I put that in my calculator, I'm going to get angle A is equal to nearest degree, so it's going to be 56 degrees. So angle A is 56 degrees. Now, I could do this again. I could use trigonometry again to solve for angle C, but there's an easier way, because all of the angles in a triangle have to equal 180 degrees. And in a right triangle, the other two angles, these two angles right here, have to be equal to 90 degrees because we already have a 90-degree angle. So I know that angle A plus angle C has to be equal to 90 degrees. And if A is 56 degrees, we can just solve for C. We can subtract 56 from both sides, and we'll get 34. So you could do trig twice. You don't have to. You could just use this angle triangle theorem here. Okay, so in this next one here, we have angle A, and we're given the hypotenuse this time, and we're also given the adjacent side. Okay, so we have the adjacent side and the hypotenuse, which means I'm probably looking at cosine. So cosine of A is equal to the adjacent side over the hypotenuse, or in this case, it's equal to 9 over 22. So what I'm going to do to get A by itself is I'm going to take the inverse of both sides. So now I have A is equal to arc cosine or inverse cosine of 9 over 22. So I'm going to put this in my calculator. I'm going to press second cosine. You'll see the little cosine to the -1 right above it of 9 divided by 22. And when I put that in my calculator, I get to the nearest degree 66 degrees. Again, I could use trigonometry to find C, or I could just know that A and C have to be equal to 90 degrees. And A is 66 degrees. So that means that C has to be 24 degrees. Okay. So we have now found all of the angles, and we could solve the whole triangle by finding these two sides as well. Okay. So we are actually at the end of today's lesson. So what I would like you to do is I would like you to practice the next thing in your green folder, or it's also on Google Classrooms if you can't find it. As always, if you guys have any questions, please send me an email or join me in the class's Google Meet for the day. I hope you guys have a great day.